right, ladies and gentlemen, what we're looking at here is section 1.2, using segments and congruency. We're going to go through a couple of definitions. We're going to talk about postulates, coordinates, distance, length, and congruent segments. Postulates, or axioms, are rules accepted without proof. They're just the rule. Okay. Like a point is a location in space. It's just a rule. Coordinate is the location of a point, like we talked about in the warm-up today. Like this point was at 2, 3. That means go to the right 2, up 3. Distance is written in absolute value. So if I want to know the distance between 2 points, and one is at -2 and one is at +4, I want to know the distance as if you were to count. So it's in absolute value, we call that. Length. Length is also called distance. Length between 2 points. And congruent segments are segments that have the same length. All right. We're going to talk about the ruler postulate. It's the points on a line that can be matched one-to-one with a real number. The real numbers that correspond to a point and coordinate is the coordinate of the point. The distance between points A and B are written as AB is the absolute value of the distance between the coordinates of A and B. Okay? So that's a lot of like blah, blah, blah. But basically it's telling you that we're just going to measure it. So I put a ruler on everybody's desk. There's also a protractor, that half circle thing, inside your box, and that also has numbers on it. But why don't you guys, at least a few of you at your table, measure this length for me right under ruler postulate. So first of all, you want to look at your ruler. Is it in milliliters or inches? The one that you're looking at. You want to make sure you're looking at milliliters. And then you want to put it so that right at 0, you're at A. And tell me the length from A to B. Anybody got in milliliters how long it is? Not milliliters. Millimeters? Yes. About 2 millimeters. And then some people get 2.1. Anybody else get something different? Yeah. 2.3. Okay. So we've got to make sure that with our ruler, do you see how there's some room at the end where it's not 0? We got to make sure the very end is at 0. And then I see 1, 2 definitely. Oh, that dot's pretty big. So I think this could be anywhere from 2.1 to 2.2. I don't think it's quite 2.3. But that's an awfully big dot. So I think it's anywhere between 2.1 and 2.2. All right, let's look at the back. Postulate 2, segment addition postulate. If B is between A and C, then AB plus BC equals AC. If AB plus BC equals AC, then B is between A and C. So let's draw a picture for that one. I just gotta hit it. Ooh. If we've got a line, and we know we have A, B, C, because it says B is between A and B. I know that if I say A plus B, so the green plus the red is going to equal the black. That makes sense, right? These between, if I add both of them together. Okay? And it's also saying the opposite. If I know this plus this equals the whole thing, I know that point has to be in between. So let's apply that for this one. I want to figure out what GH is. Well, I know, please write down the symbols as well. I know FG plus GH equals FH. Notice that I made them all segments. I'm talking about the segments, not the line. Okay, so let's fill them in with numbers. FG is what? Okay, what's GH? Don't know. So I'm going to put X. What does it equal? There we go. So how am I going to figure out what X is? Subtract, and what do I get? 15. Perfect. Questions about that? Please, 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 please write this down. Remember, you get points for writing it down, plus it will help you with your homework. Can we move on? Yeah. All right. So first I see this and it asks us to plot these points, but I'm looking at my graph and I'm like, I need an X and Y axis. So I'm just going to draw one right down the middle. And I'm going to label them. I know this one's my X, this one's my Y. Okay. And then I'm going to plot all the coordinate points that they said. J is at -3, so I go 1, 2, 3, 4. 1, 2, 3, 4. And I'm going to make sure I write J next to it. K is at 2, 4, so I'm going to go over 1, 2, up, 1, 2, 3, 4. Make sure to label it K. L is at 1, 3. Make sure to label it L. And then we've got M is at 1, -2. Okay, and then we're going to determine whether J to K, right here, is congruent to L to M. So all I'm going to do is count. Okay. I'm going to go 1, 2, 3, 4, 5. So J to K's length is 5. Did anybody else find out anything different? Okay, another way to do that is I know it's horizontal, so I can just look at the x's. I'm going from J, which is -3, to K, which is 2. What is the absolute value of -3? 3. It always comes out positive. Absolute value of 2 is? 2, so I know the distance is 5. Okay, so one I'm counting, the other one I'm just solving numerically. Okay, let's find out the distance between L and M. So first I'm going to count 1, 2, 3, 4, 5. Which letters do you think I'm going to deal with to find the distance? The X's or the Y's for this one? Is it horizontal or is it vertical? So I'm probably going to deal with the Y's. Okay, so I'm looking from L to M, so I know I'm going from 3 to -2. So the absolute value is 3 is 3. Absolute value of -2 is 2. So 5. So are they the same length? Yes. So we're going to put JK is congruent to, we'll put segment JK, LM, segment LM. Questions about this? Okay, let's look over your homework and see if I can answer any questions you might have about it beforehand. So tonight's homework is page 12, and we're going to look at problems 4 through 28. So number 4, you're going to have to use a ruler. So if you don't have one at home, you should probably use mine. Number 6 is you're just going to have to use the segment postulate. Same with 8 and 10. 12 is you're going to have to use the segment addition postulate, but you're going to have to figure out what's wrong with it. 14, you might want to use a coordinate plane. You can go ahead and use graph paper that's up here. 16 and 18, you should just be able to count those. 20, you're just going to explain if you think it's possible or not. 22, I strongly recommend you copy down that diagram on a separate sheet of paper and fill in what it gives you to be able to figure out 22, 24, and 26. And then 28 is where you're going to have to use some algebra. Do you want me to do an example that's like 28 on the board? Yes, no, you don't care? All right. If I gave you a segment, this is A, B, and C. I told you, let's say for example, A, there we go. If I told you A to, oh, goodness gracious. If I told you A to C was 10, and then I told you AB was 1. Right? Okay, let's do it a little bit differently now. So let's say AC is still 10, AB is x plus 1, and BC is 2x. Okay, so again, I'm just going to do it where it's AB plus BC equals AC. So what is AB? AB is x plus 1. Okay, and then we've got BC is 2x. And then what's AC? And then I'm just going to combine my like terms. X plus 2x is 3x. Plus 1 equals 10. Subtract 1 from both sides. 3x equals 9. Divided by 3. X equals 3. Okay, that gave me x, but did that give me the length of AB? What would I do? So 3 plus 1 equals 4. That's the length of AB. What about BC? Yep, 2 times 3 gives me 6. That's the length of BC. Okay, that example that I just did is just like number 28 for your homework. Okay, all right. We're still working on people getting books and people signing their names on the sheet. So I want you to get out your handy dandy notebook.